Hello, and a very warm welcome from me. We are going to talk about data accessibility and insights of implementing a data mesh in an enterprise, together combined with what that has to do with enterprise integration, data integration. My name is Andreas Juffinger, and I'm very proud that I'm joined today with Dr. Bernd Dammen and Dr. Mike Woodle from Kuehne+Nagel, who will tell us a bit about more their story, how they did implement that, and what insights they gained along the way in Kuehne+Nagel. I have been working in the enterprise segment since about 25 years, and I'm wondering actually how many people from enterprises do we have here? Oh, quite a few. Interesting. And who of you has heard about data mesh? Heard everybody? Who has fully fledged implemented it? We need to talk. Good. Now, thank you very much. And nevertheless, of those who you are actually working in an enterprise environment, but also in other companies, you might actually have a look at this number. Only 4% of enterprise or IT leaders really believe that the data is AI ready. What does actually AI ready mean? AI ready means the data is of good enough quality, unbiased, and very importantly, accessible. Accessible data in this context means accessible for different personas. There can be data scientists, there can be data analysts, but there can also be business people and so on. So it's quite a tough problem to make the data AI ready and accessible. We hear that only a few companies actually fully manage to break up silos. 82% of companies still report, while investing heavily into their data and analytics pipelines and so on, that they have broken up the silos. So let's acknowledge that's a difficult problem. It's not just technical, and that's why we are here to talk to you also a little bit about the organizational aspects and similar things. What we observe out there in the market are really a few things which are confirmed with data leaders, be it Jean-Marc Degani or Martin Fowler, Gregor Hoppe, and so on, is really that it makes a lot of sense if you start becoming more data-driven, if you want to embark your data journey, that you start with a centralized team. That centralized team can be excellent and well-aligned, and they can share insights and develop. On the other side, we make always the wrong assumption that we have to bring data together in one data monolith just to create value. There was always that idea of we need to have it in one place. This does not hold true anymore. There are a lot of concepts, approaches, and tools which allow us to work with data in a distributed mechanism. Because on the other side, we really see that when a data organization grows, there is a pivotal point where it actually becomes necessary to distribute. That central team will just no longer work, and you need to go in a bit more distributed mechanism. That was exactly the point where Jean-Marc Degani formulated the data mesh approach back in 2019 with the kind of headline of saying, well, data mesh is a decentralized socio-technical approach to share, access, and manage analytical data. There are two very important points in this sentence. The first one is socio-technical. So it's not just a technical problem. Coming back to the statement of the beginning, it's not just a technical problem. Secondly, for complex organizations. That's also bringing me back to the observation of before. If you have a small enough, powerful, great performing data team, why make it much more complex and distribute them and make it hard for them? So the organization needs that need for distribution. In its core, the data mesh actually develops your data warehouse or your data lake which is very much technology-driven, into a much more value-driven data marketplace. So what is a data marketplace? A marketplace always has three parties. You have the consumers. The consumers are incentivized to go to the marketplace if they can buy valuable, high-quality data products there. So you bring them there. On the other side, the producers will come to your marketplace if they have a demand, if they can expect demand on the marketplace. So they want to sell the data products because a data producer or data does not create value on its own. Data can only create value through usage. And a producer should be incentivized only by usage of their data. And not just because we're dumping more gigabytes than you onto the data lake. Yeah? Finally, in the middle, the platform, the data marketplace, is now that piece which actually needs to make it easy for both parties. So the marketplace is there to make it frictionless for the consumer to consume data, to make it easy and fast for the producer to bring the data there. When we are looking into technology problems around data marketplaces, we know Moore's law. A factor of 10 in volume and variety every 5 years. So if you build today a data marketplace, a data platform, then you will need to design in that you have about 10 times more data in 5 years. Think about 10 years, you will have 100 times more data. So there is really a technical challenge behind that. And it's no wonder that we hear from 41% of enterprises that they tell us, actually, we cannot keep up with the data. That becomes very apparent when we are going into the data integration domain. Data integration is highly demanded. So business needs more data to bring better decisions together. Data integration is highly demanded from data scientists and all different kind of parties in an organization to say, well, we need these data. And that makes it a really difficult problem for an enterprise. And data integration actually comes in 3 different styles. It depends on when and where you want to do it. If you have an application-centric data integration approach, which says, well, we are aiming for consistency across the applications. You can do an event-centric integration, where we are thinking, well, we have millions, maybe thousands of sources of IoT devices which we need to bring together in a data streaming process. And last but not least, data-centric. And we've been all in enterprises, or everybody in the enterprise knows, well, data-centric is this typical ETL, ELT pipeline technologies, and enterprises have built myriads of data pipelines with these concepts. So it's no wonder that the reality in an enterprise is that you have a lot of legacy in the application-centric integration, a lot of legacy in the event-centric integration, and of course in the data-centric. And the question now is, how can we keep up with these demands in data integration? Are there synergies to the aspiration of a data-driven marketplace data mesh? And we believe yes. And that's actually the point where we think you need to think about a holistic approach of actually bringing these things together with a data mesh, and you will find a number of synergies. And Bernd and Mike will now tell us a little bit more of how they achieved that and worked on that in Kuehne+Nagel.
Yeah, thank you very much, Andreas, for the introduction of the concepts. And now let's look how we try to do that implementation for Kuehne+Nagel. And just to give you a little bit of an background information about the domain, so what is actually Kuehne+Nagel as a company doing? So we are a logistics service provider. We are the #1 in sea freight and air freight, so shipping stuff around the world. We also have road business and a contract logistics business where we are also market leaders in different segments. We are a truly global company, 1,300 offices in more than 100 countries, very close to our customers, which is very important because the customers span from large multinational companies to really small and medium-sized customers. We have 400,000 of them, so you can see a lot of differentiation here. 80,000 people, logistics experts working on that, and out of those, more than 2,000 IT engineers located in 3 technology hubs. And one other aspect which is very important for us is the sustainability, so we're working heavily on really reducing our footprint, and that's the end-to-end footprint, so also with our partners that are delivering the goods until 2030. So what is this company and the people that are working for Kuehne+Nagel, what are they, by what are they driven? So why do they get up every morning? And when our new CEO entered the company in 2022, we worked on a corporate strategy and a vision for 2030. And the vision that we have given ourselves, you can see here. And there is 2 very important things. Most trusted supply chain partner for a sustainable future. So that is what we try to achieve and work on. And in order to get this on the road, or on the sea, or in the air, we have established a roadmap in order to step-by-step reach that vision. And that roadmap consists of 4 cornerstones, out of which one very important part is what we call the digital ecosystem. So bringing forward digital capabilities, because 2 reasons. Logistics industry is per se a very data-heavy and IT-heavy business, because we don't own assets, so we don't own ships, we don't own airplanes, but we manage the flow of goods. And that is mainly by managing data. So it has always been very close to IT. And the other part is, when we go back to the vision, trust. How do you create trust with your customers? And there is a couple of elements there. What we think is relevant, that is an extraordinary customer experience. And in order to have that customer experience, you need to know what is happening in the goods that you are moving around the world. So you have to have on-the-spot information about the things you are moving. So all available data in place at high quality in order to automate and to give best insights to your customers, and in the best case, be able to act proactively. So I don't want to have a visibility platform where I can see I have a problem with my shipments as a customer. No, I want my service provider to solve the problem before it even appears. And that is the reason why a very central and key aspect of this digital ecosystem is around data accessibility, system accessibility. Because only if we make the best use of the data we have and put them together in a proper manner, we can go ahead with automation, creating competitive insights, being proactive, and in the end, it's the basis for any high-impact artificial intelligence application. And the iceberg picture everybody knows. So the easy part is above the waterline, and the big stuff below, that's the assets where you really have to dig into. And in order to make us fit for that challenge, we started already in 2021 to transform the IT landscape of Kuehne+Nagel by introducing an ecosystem of platforms, which we at the time called KNITE Plus, which is new KNITE Ecosystem. And that ecosystem is basically setting up the infrastructure for our digital product development to a new level, consisting of 3 platforms, the IPM management platform in the middle, dealing with anything about synchronous communication between systems, internal and externally. The same for asynchronous parts, so message and event platform, high throughput, high scale, thousands of messages per second we are processing in order to follow the goods that we are that we have under management, based on Apache Kafka, API management platform based on WSO2, and on top of that, a data platform which gives the infrastructure in order to work on what we call the digital twin of Kuehne+Nagel. So that is the digital representation of the company, and I will talk to that a little bit more in detail on the next slide. So I think I don't need to talk to you to explain you what a digital twin actually means, but what does it mean for Kuehne+Nagel, and why do we think this analogy is fit for what we are trying to achieve. So again, coming back to the trust. So we truly believe that a data-driven organization, and especially making data-informed decision, will significantly improve and optimize logistics services. So this industry, by history, is pretty much dominated by gut feeling of people, but more and more this is not sufficient anymore. So we have a lot of data, and in order to make good decisions for our customers, we need to leverage that. Therefore, we initiated the digital ecosystem in order to have all relevant data, internal and external, at the fingertip, accessible and usable, and make it actionable in this corporate digital twin. The digital twin is the representation of our company's assets, key entities and processes, both current, future prediction as well as history, in order to create insights and drive also the processes of our operational systems, based on insights, steering what the operational systems and what the people are actually doing. The platform of platforms is the basis for the digital twin, as I introduced already, and maybe one aspect which is pretty much from an enterprise perspective also interesting is that by introducing the digital twin, introducing data products, which Mike will elaborate a little bit more on later, really enables us to significantly simplify and decouple the application landscape by giving the operating systems their role to do the processing and have the data products of the digital twin there in order to serve as the single source of truth for any upstream usage of that data. So, what is the digital twin? Target high-quality data, democratized, available, accessible. What components do we need for that? So we have the platform, the upper layer of the three-layered ecosystem I just showed you, which is delivering capabilities for data discovery. Self-service is very much important, not having a central team dealing with the data products and the data, but enabling the organization and the different teams to build their own data products. A lot of self-service, a lot of templating in terms of data connections, data sharing features and functionalities. Of course, you have to establish the governance piece, also very important. Consistency, lineage, data quality. Only good quality data is, only high quality data is good data. Then we have an enablement, how we call that, enablement services. So bringing the organization into this data literacy state, so teams to be able to work with data products, the data mesh concepts, our data platform, onboarding, consulting, etc., etc. And all of that finally then targets to the digital twin. And the outer circle you see here is what we actually want to achieve. So we want to have a representation of the key entities of this company being on this data mesh or digital twin to access the data for any further purposes to drive the company and the processes. How do we come to that? We start based on our IT ecosystem and the middleware, the operating systems and all the systems where the data is actually generated and changed all the time, the transport management systems, our customer relationship management system, our rate systems, etc., etc. But in the traditional way, these systems, they own their data themselves and they are not interested so much into making that accessible. And only whenever you want to have data from these systems, to use them upstream, you have to go to the system owner and say, can I please have it? Because normally they are reluctant to provide general interfaces only for specific purposes. And that we have to overcome. So the first step in the mesh is to get the data out of the operational systems. To make them available very close to the operational systems, we call them source-aligned data products in the mesh. So basically still a little bit technical, with a purpose, every change in the respective entity is exposed on the mesh. And based on these first level of data products on the digital twin, we then create what we call data stores or curated data products with high quality consolidated data from the different source systems to represent the key entities of these companies, like shipment as the central one. So everything what we are doing is around shipments, moving goods from A to B. We have associated order lines, we have capacity management with our partners, we have rates, we have invoices. And all of that is made available on this digital twin for analytical purposes, AI purposes, to do analysis on that, and feeding back into the operational systems again, but also for steering the operational systems themselves, a little bit deviating from the paradigm, from the original data mesh paradigm. So that's the overall vision and idea, and Mike will now go into some details on the data products and the data platform.
So, thanks for Bernd for introducing, and especially also for Andreas for introducing. So let's dig into the actual data platform and the data products, which is my responsibility at Kuehne+Nagel. Let's start with something like a value proposition and make the idea of the digital twin a bit more specific. So let's assume, let's do some kind of thought experiment, let's assume something. First of all, to guide you through, shipments are important to us. Data about shipments is very important. So a shipment is a request to transport something, and as Bernd already outlined, we do that quite often within the year. So let's assume the state where all shipment data for road, for sea, as well as for air can be accessed from one place. Sounds kind of trivial. However, our business unit, road, sea, and air, don't talk too much to each other. So this is already an ambitious state from our perspective. Second, the data is not only in one place, but also the data is already cleansed, checked for consistency, and maybe the special effects of certain legacy application are already eliminated. Next, the data is not only ready for analytical purposes, AI, reporting, ML, but also for operational purposes. So for orchestrating business processes. And as Bernd already outlined, this is already a bit deviating from the core concept of Dagami, saying that the data mesh is rather made for analytical purposes. Here we already say no. We also want to use data products for operational purposes, so orchestrating business processes. And next, once this is all given, we provide you as a user of the digital twin in this thought experiment, with tools to filter, transform the data according to your needs. Because this is something we cannot do, right? You have a specific use case at hand. You have to filter the data and transform according to your specific perspective you need on the data. This is what we want to achieve, and this is already quite ambitious for shipment data. However, the digital twin is not only about shipments, of course. Now we want to replace the word shipment by all our core entities. And this were the little dots on the corona of the slide Bernd just showed. So invoices, rates, orders, whatever is important within the logistic industry. How do we do that? We strongly believe in the so-called FAIR principles of data management. FAIR stands for findable, accessible, interoperable, and reusable. Quite obvious what findable means, so I have to be able to find data. Not necessarily the production data, rather on the level of schemas and examples, of course, but data need to be augmented in order to be findable. It need to be some kind of web interface or maybe even some kind of prompt to make the data explorable. Next, once I've found the data set I'm interested in, of course I want to access it. And here there need to be an easy way to one-click request the access to data. And by the nature of data products, I'm not the owner. If I request access to a piece of data, I'm not the owner of that data. There is a data product owner available. And of course, he or she has to grant that access because this is the owner. And this needs to be an automated and managed process. Interoperability means that we have data in very different kind of technologies available at Kuehne+Nagel, of course. We are doing IT since 50 years, so we have from every decade we have still a system running, I'd say, and this applies also for data storage. So here we invented, or we defined a certain set of technologies that are available to expose data in order to make the data better interoperable. And the last, but I think the most important point is we want to make data reusable. We have tons and tons of stored procedure to transform data at Kuehne+Nagel. And not only stored procedure, but also different other tools. And the idea to reuse certain transformation is, of course, the idea is not new, but the implementation, or we were limited with our implementation capabilities of reusing those transformations. How do we want to achieve that? There are two items. First of all, the data platform providing certain central capabilities for automation, data exploration, also managed data sharing and similar things. And second, the heart of our ambition, the data platform. By nature, sorted or sliced by domains, standardized in tech stack, so we have a certain set of preferable technologies that we believe, given our teams, are the easiest way to implement data products. And last but not least, we have different kind of output port types. I will come to that in a second. So what is essentially a data product? A data product is a tuple of data plus code, an API that is clearly specified and also explorable, a defined set of needed and mandatory documentation, and very important, an organizational ownership within the company. So whenever there is something with a data product, being it very positive or being it less positive, there is somebody to contact that feels responsible for that data product. Let's come to the concept of input ports and output port types, or output ports. Output port refers to the concept of how a data product exposes data to the organization. Input port types, on the other hand, is how data is fed into a data product. Usually, data products don't invent data. Data is created in our transport management systems, for example, our operational systems. So a data product needs somehow be supplied with data. This is the concept of input ports. And output ports, we support different types. As Bernd already said, there are 4 types of output port. First of all, a way of exposing data of a data product can be just by RESTful API. So I have an ID of a shipment, I do a GET request with that ID, and I get back the full state of the shipment. Task done. There are other types of users that are more interested in event streams. So I'm interested in an unspecific set of shipment whenever something is, I don't know, arrived in Hamburg, for example. So I'm filtering those messages, and whenever I found the message I'm interested in, I might trigger a business process. Additionally, we have Amazon S3 as a rather semi-structured or unstructured output pod type, so data can be exposed via a bucket. And last but not least, data can also be exposed by a set of Snowflake views. And those kind of output pod types differ also in their quality. Whereas the first and the second are rather for operational purpose. So consistency is reporting. Low latency might be very important. The later ones are rather for analytics. So for high volume, latency is not that important anymore, and those kind of things. And again, this is a bit a deviation of the original concept of the data mesh, where we believe data products should not only be for analytical purposes, but also supply other operational applications with their data needs. The combination of all data products we have, including the source application connected via input and output port, then form our data mesh, or as Bernd coined it, the digital twin. So what does a data platform actually provide? And Bernd already talked about that a bit. So we have different kind of capabilities. I believe two ones are to be a bit more important than others. This is first of all the managed data sharing. So for us, it's very important how data products are connected, which output ports are connected to which input ports, or usage of data. So managed data sharing and keeping track of that, having kind of lineage, is very important for us. Second, governance. So enabling our users, helping our users, also restricting maybe certain options, we believe gives our co-workers a lot of security to use that concept properly. So having talked about data products as well as a data platform, let's deep dive into one specific data product. And this is one of our lighthouse project, and as you already heard several times, shipments are important to us, so we implemented a so-called shipment store. And this is a single source of truth for consumption of shipments within the whole IT application landscape at Kuehne+Nagel. And if you see this picture, this is an illustrative, even simplified picture how data or shipment is flowing in the organization. So the blue ones are the systems that actually produce shipments. So shipments are created, an operator is called, somebody wants to transport something, using the UI, enters the data, and a shipment is created. And this shipment is then exposed via a message or other means. And the beige ones, or yellowish applications, are consumers of shipments. So they are interested in shipments. First problem is, of course, I have to connect to at least 3 systems, and to be fair, these are not 3, these are rather 20 systems where shipments are created, in order to get all the shipments. And this is far from being optimal. So certain applications still did this. For example, MyKN or RGS, as they call it, they did this. They implemented this kind of integration to get all the shipments. And then, of course, the next application said, well, I don't want to again reconnect to all the blue applications. I will rather connect to MyKN to get all the shipments. And this comes, of course, with certain problems. This is not the purpose of the MyKN application to serve the needs of data supply for shipments to other applications. And of course, they also take a certain perspective on interpretation of that data. This is just not their task. MyKN is our customer-facing application, so they might aggregate certain information according to what the customer wants to say. But this is not optimal for data supply of other applications. And of course, with each step of reinterpretation of the data, new perspectives might be taken. So we end up with different kind of shipments that are not comparable anymore. And this is, of course, not helpful. So what we did is, or the vision was, we want to provide one golden source of truth for shipments, and the picture on the right-hand side on the bottom describes the current state. So all shipments are provided by the blue application still. However, then we implemented the shipment store to consume this data and provide it to the organization in a unified and aligned format. And there's a yellow box with 3 dots without a name yet. This is one of the benefits. So if you want to implement an application, a new project that wants to consume shipments, they have to connect to exactly one system, the shipment store. And this comes, of course, with much accelerated time to market or time to value. Certain things are already said. And one thing Bernd already said also is by implementing those kind of shipment store or other data products, we also offload the blue application from providing yet another interface for some consumers. So they can focus on their actual backlog and not on providing data to others. And the shipment store supports 3 different types of users. The event users, and this goes very well in line with what Andreas showed on the application-centric, integration-centric, and data-centric integrations. We have the event users. These are users that are interested in a stream of shipments. And once in a while, they find a shipment they are interested in, and they trigger a business process. We have already consumers on that one. Then we have API users. Users that are interested in a certain point in time of a shipment, of the whole state of one shipment. Very different use case. They use the RESTful API provided by the shipment store. And last but not least, the analytical users, they are interested in all kinds of shipments, usually also including deleted shipments, history, and the full history of shipments. Latency is not that important anymore, and they run very complex queries and aggregation on that data. And this is all supported by the shipment store and, of course, similarly by other stores as well. Our shipment store is implemented in AWS and makes heavy use of the Kuehne+Nagel New IT Ecosystem, meaning fed by messages on the message and event platform and exposing, as just said, data on the message and event platform, API management platform, and on technology supported by KNITE data. Before concluding, 2 things I would like to highlight that helps us on our journey. First of all, the so-called data product canvas. This is an ideation artifact. It's open source. We adjusted a bit according to our needs, but this is just minor. And this is really an ideation artifact. So before implementing any piece of Python script, SQL, whatsoever, sit at a table or in MS Teams and look at that artifact and discuss what's the actual purpose of a data product. And we usually start from outside in, saying, what are the use cases that are supposed to be supported by this data product? Who would be the consumers of that data product? And then taking the very different perspective, which system need to be connected in order to fulfill that use cases, so the sources. And in the second step, it's also worth to look inside and say what kind of transformation are to be performed, which frameworks are to be used, and similar things. But this fostering that product thinking is a really hard part in our journey on the data mesh or data product development, and this artifact helps us quite a lot. So in each and every onboarding, we use that kind of artifact to better understand what's actually needed. And second, we use booster squads. This is our way of fostering the adoption of our concept. We built the data platform, and it's shiny, but not as much used as we want it to be. So actually, the value is not created by implementing a data platform, but as Andreas showed, by actual consumption of data. So our solution is that my teams not only act as data platform engineers, but also reach out to our customers in order to help them implement the data products. And how do we do that? First of all, we provide a lot of onboarding support, which includes, for example, the data product canvas. We have also continuously consulting of data product teams within their journey on data product development. We, of course, implement or define best practices, especially with customers that joined us. Next, we develop so-called KN bricks. These are reusable Terraform templates in order to accelerate the development of data products. We implemented or compiled a set of learning paths that help the organization to increase their data literacy or the technology literacy when it comes to technologies involved in building data products. And last, but I think most importantly, we co-build, meaning that my platform engineers join teams and make their hands dirty in developing data products. And this not only gives provides trust to our teams, but also is a very valuable source of actual requirements and pain points of using the data platform. Here are some figures about what we are doing in that regard. So we're doing quite a lot of onboarding requests per week, given that we have not that big team. We active consult currently 13 data products, and we have certain other pieces already available. To conclude,
so am I on? Yes. So just wrapping up. So we started with our vision, become the most trusted supply chain partner for a sustainable future. Trust you gain with delivering to promises and being proactive, and that is really based on making the most out of your data you have. 3 steps we try to illustrate. First of all, we need to get the data out of their silos from the operational systems. They are there for specific purposes, but we need them far beyond that domain in order to bring things together and really steer the company's need. We do that by introducing data products on a domain level, so specifically for the different entities and domains, business objects that are central to our business. And in order to also then feed back the automation and the steering based on the insights we gain on the data products, we heavily have to invest into proper APIing, both the data products as well as the operational systems back. Make the data actionable. You can only work with it in a proper manner if you have high quality data. So very important aspect on the platform is to significantly improve end-to-end data quality, making operational systems and operators aware of they have to also consider the quality of the data that they are inputting, because they will propagate through the digital twin going forward. The data product ecosystem or digital twin, we really need to design this twin according to the needs of the company. So what is the most valuable part of it? What is the core entities that we need? And that gives us the opportunity to apply AI and do further automation. To then finally make sense out of data by adding value-added services, to gain further insights, to be proactive, and also to be able to apply all these methods at scale and not just for a single use case, which is always kind of an easy thing to do. And the overall theme here is breaking up silos, so making the organization aware that data is an asset that is not needed just for the ones who create it, but it's needed for everyone in the company to be better towards our customers and to deliver the services that we want to deliver.
So again, some further key takeaways from our learning. So first of all, we believe that data is important, gaining insight of data is important, but it cannot stop there. You need APIs further. So this goes in line with the overall idea of KNITE, having 3 different platforms, not only for data, but also for orchestrating business processes, because once you gain insight, you want to further automate, and then you need APIs again. Second, product thinking is difficult and requires upskilling with our teams. And second, also, with our way of treating data so far, even good software engineering practices haven't been that often, frequently mature used in our way of treating data. So these are 2 aspects that require upskilling. No data platform will sufficiently achieve a state where data is available. You have to push to get critical and important data for your business process onto the platform. This will create new demand, and this will make people join. And of course, if you want to apply AI and ML at scale, you need high quality data. In order to get there, you have to apply management practices or data management practices in order to get to high quality data.
I only have to say thank you. Thank you.
Thank you.